So today we're going to talk about factor by grouping again. There's going to be an extra step in here today. And this was actually the stuff that you guys struggled with the most. This might be actually even something you guys struggled with the most all year. And this is when we have that little extra piece just hanging out with our factoring that we're just like, what do we do with this extra piece? Well, I'm going to show you right now. So looking at this polynomial, notice it's quite large, right? Well, the reason for that is it's basically got a little extra something in there. So one thing that I'm going to do right now, and you can actually do this later in the process, and maybe I'll show you guys how to do it later in the process on the next one here. But for this one, let me show you guys a little trick. So I've got some pretty big numbers here. So one thing you can do is you can look to see if there is a greatest common factor between all of these before you even start, and then take that out. Okay, so I'm going to actually get my calculator out now because there's going to actually be stuff that I need it for on this one. So looking here, I've got, there's not an n in every term, so there's n's not a greatest common factor. Looking at the numbers, I'm going to look at the smaller ones first and see if there's a greatest common term. Like this, 21 is 7 times 3, right? 30 is 10 times 3. So basically we're going to look to see if 3 is a common factor that can take out all of these. I'm pretty sure 360 can be divided by 3. It's 120. 252 I'm not sure about, so I'm going to check. So 252 divided by 3 is going to be 84. Okay, so that means I can take out a greatest common factor of 3 before I even start. So I take out 3, that's going to leave me with 120 n to the third plus 10n to the second plus 84n plus 7. Okay, now when we did this before this year, I had I don't know, anywhere from a third of you to maybe even half of you that would take out that greatest common factor, and then it would just disappear, go into magic land, just gone forever. No, that 3 is still there. It still needs to multiply back out when you're done. Otherwise, it's not going to be a completely factored form. You're not going to get this original polynomial back. Okay, so that 3 is still there. It's just going to kick it out front for the rest of the time. It's not going to go back in. It's just the 3 is always just going to be right out front the whole time. Okay, now we're going to group. So group our numbers, and let's see if we can figure out greatest common factors. So right off the bat, I know that 10 goes into 120, so this should be pretty easy on a factor. There's 2 n's in each of these, so I can take out an n, 10 n's to the second out of that first one. So 3 times 10n to the second times, I would be left with 12n, and then I'm taking out that entire term, but it would just be a plus 1 left there, right? You still need a spot to like multiply it back through. Okay, then we're going to see, does 84 divided by 7 is 12. So 7 goes into 84, so I can take out a 7 from each of those. So if I take out a 7, I'd have plus 7 times 12 and plus 1. Great. Now I can take those, factor them in front, but not in front of the 3. The 3 is still there. Okay. Factor those in front, and then I'll have my second one will just be what's left there. So I'd have 3 times 12n plus 1. And then what do I have left? 10n squared and 7. So times 10n squared plus 7. And that would be my factored form. Okay? That is what would multiply back out to get the rest of my equation. Again, you can test that, multiply the 3 back out, then distribute, and you should still end up with this original polynomial right there. Okay? Let me show you guys how to do it without taking out the greatest common factor first. I don't advise this because then you're looking for extra things to factor after everything should already be factored. But you can still factor by grouping just like you did before. So let's try it. So let's factor, or let's group. And again, if there's a minus, you're going to do plus, minus, and then group. Just like that. And then let's factor things out. So 24, 72, does 72 get divided by 24? It does. So I can take out a 24 out of both of those. 24a squared. So I have 24a squared. Okay, being factored out of there. And then 24 goes in 72 3 times, so I'll be left with 3a and then plus 1. Okay, then let's see if 66 goes into negative 66, goes into negative 198. So negative 198 divided by negative 66 is 3, so it goes into that 3 times. So I can take out a negative 66. So I have minus 66 times 3a plus 1. Okay. All right, so far so good. So then I can factor out the 3a plus 1. So 3a plus 1. And then I'm left with 24a squared minus 66. Well, this is why we have a bit of an issue, because those are very big numbers. And that's because they still have a common factor that can be simplified even more. So if we look at this, 24 is the same as 6 times 4. It's negative 66 is the same as 6 times negative 11, right? So they both have a factor of 6 that I can take out and move to the front. So I'm going to take out the 6, and I'm just going to move it to the very front over here. It doesn't really matter where you put the 6, because no matter which one it multiplies through, it's going to end up multiplying to everything anyway. So 6, and then I'm going to be left with 4a squared minus 11. And now it is in its completely factored form, and I have solved it. Again, if you can, take out that greatest common factor to begin with, but even if you take it out at the very end, you're still going to end up with the right answer. Just this is not the factored form, this is. So even here, make sure that you can't take out anything that's still in either of those parentheses. Okay, if you have any questions, just ask your teachers. We're here to help.